Hello. In this module, we will be talking about Bernoulli trials and Bernoulli distribution, which is one of the discrete probability distributions. Let's take an example of an experiment when someone tosses a coin. The possibilities could be a head or a tail. Similarly, when a baby is born, it could be a baby girl or a baby boy. When a treatment is given to a patient, there are possible chances that there will be a success or a failure. Moreover, if a mosquito bites, a person may get malaria or may not. In all these four situations, we find that there are two possible outcomes. Whenever an experiment or a trial produces two possible outcomes, either a success or a failure, that's called a Bernoulli trial. It is named after a Swiss mathematician, Jacob Bernoulli. So the Bernoulli distribution is a discrete probability distribution having two possible outcomes. Let x be a random variable that follows the Bernoulli distribution that occurs as a result of a Bernoulli trial. X can take two possible values. It could be 1 or 0. It will take x equals to 1 when the outcome is success, or 0 when the outcome is failure. So if P denotes the probability of success, then 1 minus P will denote the probability of a failure in any Bernoulli trial. Then the probability mass function of X, which follows a Bernoulli probability distribution, can be written as a probability mass function P to the power X 1 minus P to the power 1 minus X, where P to the power X will talk about the probability of success to the power the number of times the success occurs. Here X could possibly take 0 and 1. X will take a value 0 when there is no success, and it will take a value 1 when there is one success. Here, I want to mention one thing, that the Bernoulli distribution arises from the Bernoulli trial, and it only talks about one trial, single trial. So whenever there is a single trial, there will be either a success or a failure. That's the reason X can only take values 0 and 1. Let's take an example where we have a random experiment of the birth of a child. There are two possible outcomes. It could be a baby boy or a baby girl. Let's say our event of interest is the birth of a baby girl. Then our success will be the birth of a baby girl, and the probability of such a success is going to be denoted by P. Whereas not having a birth of a baby girl will be considered as failure, which is 1 minus P. So from this random experiment, we got a random variable X that's denoted by the birth of a baby girl when X can take values 0 or 1. This probability mass function can only be true for the values 0 and 1. But if X takes any other value, let's say 2, then the probability mass function will return the value 0. So in an experiment of the birth of a baby, let's say probability of success P is 0.60, which is 60%, and failure is 1 minus P, which is 1 minus 0.60, which is 40%. Then probability of X is equals to 0 will denote that there is no baby girl born. This probability can be obtained by using the probability mass function of the Bernoulli distribution, and the result turned out to be 0.50 or 0.40. Whereas the probability x is equals to 1 will help us to find out the probability that one baby girl is born. And the probability for achieving this success is 0.60. Similarly, this can also be described using a histogram, where 0 reflects that the probability on x-axis we have the possible values of a random variable, and on y-axis we have the probability of x. From here, we can see that when x takes value 0, the probability is 0.4, and when x takes value 1, the probability is 0.6. You want to make sure that P and Q, they both adds up to 1, whereas Q is equals to 1 minus P, which is the probability of failure. Bernoulli distribution has different other characteristics. One of them is the mean, and the other one is the variance. Mean is also known as the expected value, which is obtained by the sum over the values of x multiplied by their respective probabilities. In this situation, since we know that x can take values either 0 or 1, and the probability of success is denoted by P and probability of failure is denoted by 1 minus P, hence applying all those values into this formula, we get that the mean for the Bernoulli distribution is denoted by the value P. Using the example we've been working with, when P is equals to 0.6 and 1 minus P is equals to 0.4, the mean of this distribution will be 0.60, which is same as P. Whereas the variance is the expected value of the x square minus square times expected value of x. Simplifying this term will show that the variance of the Bernoulli distribution is P times 1 minus P. For our example, for the birth of a baby girl, its variance is 0.24, which is apparently the 0.60 multiplied by 0.40. 0.40 will be obtained as a result of 1 minus 0.60. The Bernoulli distribution is the simplest discrete probability distribution. It's a building block for other more complicated and complex distributions like negative binomial distribution, and geometric distribution. In our curriculum, we will focus on the binomial distribution. Thank you.